other communities are also there.
And till now they are from diploma only.
Okay, diploma student.
Yes, ma'am. All streams are there, ma'am.
Okay. Diploma which year?
Mainly third year and second year, ma'am. Till now.
Oh.
First year will also join. They are more enthusiastic than the rest of the year. They are more eager to learn many things.
And these batch, so they are missing regular classes, so they always prefer this kind of interaction.
Yes, ma'am. After 2-3 minutes, we will start, ma'am.
Many students are joining, so let us wait for 2-3 minutes and then
Yes,
start.
yes, ma'am. Thank you.
অভিনন্দন স্যার, শুরু হয়ে গেছে নাকি?
না স্যার, শুরু হবে স্যার। আমরা একটু ওয়েট করে নিচ্ছি স্টুডেন্টদের জন্য। হ্যাঁ
হ্যাঁ, ঠিক আছে।
So we can start the session now.
Okay.
Welcome, ma'am.
So good evening to everyone.
Ma'am.
Yeah.
Yes, ma'am. Let me introduce, ma'am. Give me 2 minutes, ma'am. Please, ma'am. Yeah. So, on behalf of Sri Ramakrishna Institute of Science and Technology, we welcome Professor Dr. Oishila Bandhopadhyay. She is an assistant professor at Computer Science and Engineering, Indian Institute of Information Technology, Kolani. She has completed her PhD on 2016 from Indian Institute of Engineering, Science and Technology, Shibpur. Her research area is on computer vision, medical image analysis, and digital geometry. She has published many uh, journals and attended many conferences in a well-reputed like Springer, Scopus Index, and IEEE. She is a member. She is a member of IEEE Computer Society and Computer Society of India. She is also the reviewer of computer methods and program in biomedicine and Elsevier Journal, Information Science from Elsevier Journal, and IAPR Computer Vision and Image Processing. She has a huge field of experience she has a huge field of experience in computer vision, digital geometry, and her teaching experience is she is presently working in IIIT Kalani. Before that, she was in IEM and NITTR Kolkata also. She is a research fellow at DST Women Scientist. So I welcome again, ma'am, for giving us your time and enlightening our students in a new vision, in a new way of thinking what the technology can do for the society and for the youth. So, ma'am, you may please start the session.
Thank you, sir. So I welcome you all in this lecture session. As far as I understand, most of the students are from second year, third year of Polytechnic. So you are quite young mind and you have the interest to learn new things. That is very good for all of us. What I am trying to cover in today's lecture is basically the introductory part of these buzzwords like computer vision, image processing, computer graphics. What do you mean by these things? I'm not going to discuss any research topic here because you people are quite young and you don't have the prerequisite for going to directly to research topic. Rather, I want to focus on few problems where we can apply this type of knowledges and how we can solve day-to-day problems using knowledge of these subjects. So let me share my screen. I'm switching off the camera mostly because it may cause problem in audio later. And my request is, I am using many terms here. Whenever you have any query, please make the session interactive. You ask and end up the discussion also. I will try to give answer to your queries so that you can enjoy the session. This is not, should not be the one-way communication. So that is my request to the students. I hope the screen is properly visible to all. Is it okay?
Yes,
Yes,
ma'am.
ma'am.
No, ma'am.
Okay. Thank you. So, yeah. The title I have mentioned here is the computer vision and image analysis concepts and applications. And my institute, as your sir has already mentioned, IIIT Kalyani. Now, let us come to the topic. What do we actually mean, or how do we define computer vision? The very basic definition, if you search over internet, if you search over books, you will have the definition something like this. Like computer vision is a field of artificial intelligence that trains computers to interpret and understand visual world. Now, three important words, a set of words I can say mentioned here. First thing is field of artificial intelligence, or the very common term we are using nowadays, AI. What it does, train computers to interpret and understand the visual world. So, two things comes in picture. First is the understanding and as well as the interpretation. Given a particular scenario or particular image or particular snapshot, if I look at a particular image, say this is the image of a music album, cover page of a music album. If any human being look at this image, what all information he or she can gather from this one? 4 persons, they are crossing a road. This is a pedestrian crossing. There is a particular car which is parked not properly, partially over the pedestrian pathway or footpath, you can say, partially over the main road. At the same time, other cars are waiting because the signal is on for pedestrian crossing, is not on for car, but the signal is not visible here. The terms I have mentioned, first thing is 4 persons crossing the pedestrian crossing. Second point I have mentioned is a car standing, which is parked, but not properly parked, partially on pavement, partially on the street, main road. Third point I have mentioned, other cars are waiting. Okay, these 3 informations, and other cars are waiting. First car I can see from this image is a black one. The car parked nearby the pedestrian crossing is a white one. And the color of the dresses, their appearance, long hair, short hair, all these things we can conclude from this particular image. Now, whatever I have mentioned, among that, how much my eye can visualize and how much information I am actually sharing from my previous knowledge. Just think about it. My eye can visualize 4%. I know these 4 entities or these 4 objects present on the screen, present in this image, are human beings, because I know how human being looks. So I am not saying 4 dogs or 4 cats are crossing the road. I am saying 4 human beings are crossing the road. Fine, because I know how human being looks. This is the first point. Second point is about the color of the dress. Color of the dress I can comment because I have the idea of different colors. Third point I have mentioned, they are crossing a pedestrian crossing. I know how pedestrian crossing appears, so I can mention that. Fourth point I have mentioned that car is parked nearby, which is not parked properly. It's parked partially on the pavement, partially on the road. So, how do I conclude that? Because I can find out the barrier of this main road and the pavement. So, up to this, my vision helped me to gather this information, as well as my prior knowledge helped me to take some conclusion or make some understanding of this image. At the same time, I have mentioned in my first statement that other cars are waiting. It appears the signal is on for pedestrian and off for cars. So this comment is entirely based on the experience or knowledge I have gathered while crossing a road. That means when human being look at any scene, any image, he or she use the visual information collected by her eyes. At the same time, the information already stored in brain based on the prior knowledge. And what we are trying to do whenever we are visualizing any image, we are trying to understand the image, we are trying to interpret the image. What is the understanding part and what is the interpretation part here? I can see the image. Just looking at this, I can see the image means I can count the number of persons, I can identify these are the persons crossing. Now, what is the understanding? The understanding is these persons are crossing the pedestrian crossing. That means the signal for pedestrian is on. At the same time, I am commenting these cars are waiting. That means signals for transport or vehicles are off or red signal. And for pedestrian crossing, it's the green signal. So this is the understanding. Similarly, when I am mentioning that this car is parked nearby, but not parked properly, partially on pavement, partially on street. This is also understanding and interpretation. Just by looking at the position of this car, the line of the separation from street to pavement, I am commenting that it's not parked properly. So that is the explanation of this word interpret and the explanation of this word understand. So just like human being, when we are going to study the subject computer vision, or when we are discussing something about computer vision vision technology also try to look at any image or any video, just like human being, try to find out the interpretation and the understanding of the visual world available in front of the machine. And the programs written for computer vision are mostly doing the working towards that objective. So this is the very basic idea about computer vision. Let us come to some formal portion. So computer vision, you can say computer vision enables computers and systems to derive meaningful information from digital images. As I have mentioned in bold, meaningful information. That means, as I have shown in the previous image, we are trying to make some comments based on the information available in the image. Like the position of the car I have mentioned is not parked properly. Other cars are waiting. 4 persons are crossing and no car is coming towards the persons. That means they are not in danger. So that information is also a meaningful information. At the same time, take actions or make recommendations based on information. What type of action? Say if I want my program to find out whether any car is parked wrongly near the pavement crossing, it will identify that. That is the action. Or if I say whether any car is moving towards these pedestrians in spite of all red signals, then also it will mark those type of cars when the car is crossing the minimum distance required from pedestrian crossing to the car when the signal is off. So those are the actions. That means this is the domain where we always study the image or video or other visual inputs and find out the meaningful information, take action or make recommendations based on the information available. So if we say that artificial intelligence enables computer to think, we can say computer vision enables them to see, observe and understand. That's why artificial intelligence and computer vision, they are very closely related. And computer vision mostly use the artificial intelligence techniques to observe, to understand and to act or recommend based on the information available. If I want to compare human vision with computer vision, how it will appear? First thing is, human sight has the advantage of lifetime of context. As I have already mentioned, from prior knowledge, I am telling that signal is off, signal is red, and that's why all cars are waiting. Pedestrian signal is green, or pedestrian signal is on. That's why these people are passing. So these are the prior knowledge. And human brain has this prior knowledge. They are gathering that prior knowledge from the very beginning of their childhood, and throughout the life, they are collecting these knowledges. I hope all of you have seen that little kids, little child, they can't find out name of different animals, domestic animals, and their parents or their elders always show them, see, this is called cat, this is called dog, this is called goat, like that. That means what? When we are doing that, we are giving a kind of training to the brain, child brain. They are recognizing, okay, this shape is basically known as a cat. This shape is basically known as a dog. So that is the way they are learning, they are gathering knowledge. And this is a lifetime knowledge. Human brain has no limitation that it will only recall last 4 years knowledge, last 3 months knowledge, something like that. It happens on when brain has some disease. Otherwise, we can recall very old knowledge also. That is the special capacity we have. At the same time, this is the memory part we have. At the same time, when we are doing this kind of thing, what all organs involved? We have retina, we have optic nerve, we have visual cortex. Those are involved in human vision. To train how to tell about objects apart, how far away they are, whether they are moving or there is something wrong in that image, all these informations we can immediately find out with help of these organs. What happens to computer vision? Computer vision trains the machine to perform these functions with the help of camera, data, and algorithms. Algorithms are basically, I hope you are familiar with the term, the logic you are using, the steps you are using to generate your program. And the camera is basically your input device through which you are collecting the image. Data is your image here. Image itself is the data for computer vision problem. Now, what are the related fields? Along with computer vision, we are having several fields related. 3 major components are computer graphics, which deals with models to image, or we can say computer graphics is basically study of digital synthesizing and manipulating the visual content. Like we are having a 2-dimensional straight line. All of you know you are having given a coordinates of 2 points, x1, y1 and x2, y2. You know how to draw the straight line. You know how you are forming y equals mx plus c, and you are generating a straight line. Now, given a computer graphics algorithm, if 2 points are given, your graphics algorithm can draw a straight line. Your graphics algorithm can convert the straight line to a thin rod if you are moving towards the 3-dimensional space. So, computer graphics is basically dealing with the shape and models, conversion of models to images. At the same time, computer photography, we are having input also image, output also image. And computer vision, taking input as image, most of the cases we are generating some model. We are developing some model which can perform some particular task. We will come to that slowly. And this is a very interesting table, we can say. Left side also I have mentioned the items image and knowledge. Here also image and knowledge. Now, this is my input set and this is my output set. These column headers are output and row headers are input. When we are taking input as image, we are generating also input output in form of image. What we are doing? Most of the cases we are doing digital image processing. You take input as image, and output also. Image is digital image processing. Input as image and output is knowledge. That's why I have mentioned model. You are moving for computer vision. Similarly, your input is a knowledge, set of knowledge. Your output is image, graphics, computer graphics. As I have mentioned that given two endpoints of a straight line, draw the straight line. You will write some algorithm that will be the algorithm of computer graphics. What you are doing? Your knowledge is the start point XY coordinate and end point XY coordinate. What is your outcome? Outcome is a straight line, which is basically straight line image. So, knowledge to image. You are working on computer graphics. Knowledge to knowledge, this is artificial intelligence. When you are giving input in form of some knowledge, some meaningful data, you are generating output which also gives you some information. That is the domain of artificial intelligence. So if you can remember this particular table, you will have no confusion, because most of the cases I have seen students are very confused about when we are, what is image processing? Yes. Hello. Any question? Okay. Okay, sir.
Hello.
Yeah.
I have questions, sir.
Yes.
Acha, ma'am, what is image processing? I don't understand this.
Yeah. Slowly. I am coming to that point. I will discuss about image processing. You keep on listening, you will get your answer. I know these terms are very new for you people. So I will come to that point. What is image processing? Before that, we have to understand what is digital image. Okay. So these are the another type of mapping of computer graphics, computer vision, machine learning. And I think this diagram actually represents the entire field of computer graphics and vision, where we are having artificial intelligence, machine learning, cognitive science. Cognitive science deals with human mind study, scientific study of human mind. This is another interesting subject where you have overlapping of psychology, human brain study, human behavior study. So many things are there. So this is also a part of computer vision. This has some contribution in computer vision. At the same time, algorithms are there, image processing, graphics. All these are different subject, independent subject, but they all are providing some components to computer vision. These are interdisciplinary subject where we are using the knowledge of all these subjects.
Madam.
Yes.
Yes. Bolchi, ma'am, I have another question. Why we use computer vision and what is the function of computer vision?
I think, Jaideep, you wait for end of the lecture and I will answer all the questions at the end of the lecture. That will be better because I will discuss these points during my lecture. Okay, you write down your questions and once we complete, then we will answer all these things. So, our target is to make the computer understand all these images and videos. What kind of scene? If it is given the scene, where are the cars, how far is the building, all these informations. And we know that vision is basically a complex process. Most of the portion of our brain, if we study, we can find out a considerable portion is devoted for human vision. And there are different types of application of computer vision, like your safety. You know this today's auto car systems everywhere. If it is not fully auto driven, then also in today's microprocessors, you have the indicator when you are crossing a minimum distance between two cars. Your indicator beep. You are getting the alert that you are crossing. You have a car in front of you to avoid collision. So this type of devices are actually working on the algorithms of computer vision. Medical image analysis in the health and medical clinical side, we are having in this disease diagnosis. That is also a part of computer vision. Security. Everywhere you are having the CCTV camera. And CCTV camera with a computer vision enabled software can detect the intruders, any kind of abnormal behavior within your shop. Those things are possible using computer vision. Then your entry card, access card, you are using for login, punch card, any kind of video game, animations, all these things are related and all these are different applications. And here is a history of computer vision. Started in 1966, long back, when some professor Minsky, he assigned a project to undergraduate students and just asked them to capture the images with their camera and then use computer to analyze those images. So that was the beginning in 1966. And after that, we came a long way with different types of image collection, image analysis algorithms, then artificial neural network, face recognition, and 2000 onwards, all these things get speed up because of the advancement in the architecture of computer, the high-speed processor, and now we are having the GPUs. With that, we can perform the computer vision analysis and the processing algorithms. Now comes to the basic idea of digital image processing. What do we mean by the image? We can say that image processing operation, we can define it in form of a function that typically defines a new image in terms of existing image. So we can have some representations, say gxy. This is represented in form of t of xy. T of fxy is a function, or we can say f of txxy, tyxy. Why I am using the term xy? Because image is represented, digital image is represented in computer screen. Now, what is digital image? When you look at any image, just look at this image. Only this portion. These particular lines, why these are visible to you? Because these lines are black and this portion it is white. Now, what is black and what is white? This entire region is represented by very small dots, or we can say if we think about a grid, or you can visualize it in form of a graph paper, which is you are very familiar. And the intersection of horizontal and vertical lines, you can say that is a pixel. Pixel means the dots present on your screen where you are providing the instruction that this dot will be on or this dot will be off, or this dot will be black or this dot will be white. Based on that, the entire image will be visible to you. Like this image, you see the background is dark, background is black, and the lines are white. That's why these lines are visible. If both black, it can't be visible. So you should have a background color set for the pixel, should have a foreground color set for the pixel. In case of color image, there are given multiple colors in class. In case of black and white image, the only black and white two colors are present. So what I am trying to say is, digital image is represented in form of a collection of pixels. And how it is actually represented in your system, in your computer, you can say in form of a matrix. I hope all of you are familiar with the term matrix in mathematics. If I have n cross n matrix, that means n rows and n columns. And every n cross n, every point is represented by the ij, which is then a row column index for that particular point. So if I am saying that I want to find out the value of 5th row 6th column, then how we are representing it? A56, if A is my matrix, then A56 element I am trying to find out. So that is the way we represent image in computer, or we represent image in program. That is, every image I can think about in form of a matrix of the size of the image. You know how image size appears. If you open any image or in your window, in your Explorer, if you try to right click and find out the size of the image, it always appears like 600 × 300, 600 × 400, or 200 × 300, something like that. What is this 200? What is this 300? Dimension of that matrix. So every pixel is represented in form of Pij, and the value at that particular Pij. That means, say 5, 6, 5th row, 6th column. What is the value? If it is a binary image or black and white image, the value is 0 or 1. 0 means it is a black pixel, 1 means it is a white pixel. If it is color image, if it is grayscale image, that means my value can be 0 to 255, any value. And that will be shown as a grayscale, like this image. Any variation between black and white. If it is color image, then in case you will have 3 colors, red, green, and blue. That's what is mentioned here. In case of color image, you will have 3 colors, and you will be able to see any combination of red, green, and blue in the particular pixel value. So in case of color image, you will have one matrix, you will have a matrix of n × n × 3. So n × n is a 2-dimensional matrix which is representing 2-dimensional image, what we are dealing with normally with grayscale. And n × n × 3 is basically representing 2-dimensional image in color, or in the true color we say red, green, blue, RGB color. And each pixel will have 3 values. Say for red, the value is 200. For green, the value is 150. For blue, the value is 100. Something like that. Every value will vary between 0 to 255. That is the range. So that way we represent the pixels, and image is collection of pixel, nothing but collection of pixel. We define image in form of a function. Why in form of a function? Because every image will be represented in form of collection of pixel. How I identify pixel? In form of XY coordinates. So the image should be GXY or FXY, whatever. But it should be a function of XY. And what is XY? XY are the special locations or coordinate points of the pixels. And value at point XY will give you the intensity of that point. As I have mentioned, for binary image, this is 0 or 1. For colored image, you will have any value between 0 to 255 for RGB, red, green, and blue. For grayscale image, it is 0 to 255. Now, what I have mentioned here, transform. We can perform transformation of images in the range of F. What is transformation? Say, you know, in Paint, I think all of you have used the Paint editor in your school to draw the image or to perform some operation on the image. What you used to do? Select the image, drag it, increase the size, increase the height, increase the width. So what you are doing? You are performing some kind of scaling. That is transformation. That's why I have represented transform in form of GXY. The new image will be some operation T on the existing image. Or you can shift the image from a particular position, present position, to next position, right side or left side. That those things you have done in Paint. And that is the thing we are actually mentioning it as transformation. So I will show you some demonstration if you are interested once we complete this discussion. Now here comes where we are. I started with computer vision discussion. Now I am talking about digital image processing, now how it moves. So computer vision, actually this entire subject, we can have a 3-phase discussion, like low level process, input is image, output is image. And I have already mentioned it, both input and output is image means we are doing something with image processing. So what we do actually within image processing, like any kind of noise present in your image, removal of noise, sharpening of image. So these things can be done in image processing. Now, second level or medium level, we are having input as image and output as attributes. So input image and output attributes, you can perform image processing as well as image analysis also. Like I am performing object recognition, I can perform segmentation. That means I can extract some portion from the image. Say I have an image of one person and a dog. I want to extract only the image of the dog. That is segmentation. Segment that portion from the image. So that portion comes to the image analysis. And then you can have high level processing where we are having the attributes. So after image analysis, you send it to high level process, have the attributes as input, output is your understanding, your model. Here comes the computer vision. So you are having the scene understanding, you are having the autonomous navigation, all these things. So basically computer vision, we are having different phases of image processing, image analysis, and then with help of artificial intelligence, you are moving towards computer vision. And these are the very basic key stages of digital image processing. As someone asked me, what is image and what we are actually doing with this. So these are the things where I am starting from here. Problem is image acquisition. That means your collection of image. You have the digital camera, you know how to capture the image, you have the source of light, you have the scene element, click your camera and generate the image. This was the thing I was talking about, the digitization of image. What is digitization? See, this is just like a graph paper. This is basically the grids. And we have the vertical and horizontal lines at the grids, and each intersection where vertical and horizontal intersect, I am mentioning it as my pixel. So grid points, we are considering pixels. Now, how image is formed in my digital domain? See, some of the grid points, this is the background. Background is empty. I have not assigned any color to the background, any values to the pixels. Where I have assigned values? In this region, which is basically the component of the image. And I have assigned different values between 0 to 1, between white and black. That means this is basically representing a gray image. And why this is, I am mentioning the values will be from 0 to 255. I am getting this particular number 255. Basically, we are using 8-bit to store that information. 8-bit means we will have the range from 0 to 255 to the power 8 minus 1. So the individual pixel intensity values will vary between any range from 0 to 255. And if you vary that range, you will have different values of this, different appearance of this white and different shades of gray. So this is basically the acquisition or capture. Go to the next one, image enhancement. What we are doing in enhancement? Given the image, you can perform some process to increase the contrast. I hope you understand what do you actually mean by contrast. Contrast means if I am having a background and a foreground object, like this one, I am having the backgrounds and these seeds or nuts, they are appearing in the foreground. Now, when the foreground will be clearly visible to you. See, this left side image, it is not clearly visible. Why? Because the intensity difference is not very high. This is black This is white, but very close to black. It's not very prominent. But if I perform some operations, some process, and increase this intensity difference, increase this contrast, then your image appearance will be much clearer. That's what is happening here. And this process is known as image enhancement. So this is a particular portion of image processing where we perform this enhancement and make the image more clear for visualization. Now, third one is image restoration. What is restoration? Given the image, you will perform enhancement, but then also it is not that much clear. There are some noise, there are some additional components present in your image matrix. That's why it's not very clearly visible. You perform some more operation and restore the image. That's why what we are doing in image restoration. Then morphological processing. Till now, we are discussing about given the image, perform some operation and make the image more clearly visible to us. Now, when we are talking about processing, processing is something where you are performing some operations so that you are changing the input. Here, morphological processing is a particular subject where we are trying to perform some operations on the image matrix and doing some fine corrections in the image. This input image is the image of thumb impression or fingerprint. Now on this fingerprint, if you take the fingerprint, I hope many of you are familiar with how to take the fingerprint. Take the fingerprint by placing your fingers on pad, colored or stamp pad, and place it on white paper, you will have the fingerprint. If you look at the fingerprint, it appears like this. And these lines are very unique for every individual. That's why we consider fingerprint, human fingerprint, as a biometric component for identification of that particular human being. And in many cases, like your Aadhaar card or your exam forms or admit card, they ask for fingerprint. So this is the reason, even many legal documents also, registration, all these things, they ask fingerprint. So why? Because these lines are very unique. Now, this is a fingerprint processing image where we have the input fingerprint, but some of the lines are not that much clear. So we have performed some morphological operations here and make the line more clear in the final image. So there are several applications of morphological operation. I am not going in detail about morphological operation, but my point is what we are actually doing. So here we are performing some fine tuning of the image. Next one is segmentation. As I have already mentioned, segmentation mainly deals with extraction of some portion or some important portion from the image. Here, extraction of some portion, what we have done, we have basically extracted, basically removed the shadow from the image. Just look at the first image and the second image. We have removed this shadow part and apply our segmentation logic, segmentation algorithm, and extract the main object without shadow. And this is called the histogram of the intensity distribution. And this very high peak represent most of the pixels present in this image are basically the pixels with white or 1 values or 255 gray value, and very few pixels belongs to the black or 0 value or present in this image, because my object is only having the black side and the ground is white. This is segmentation. Then recognition of the object. Once you perform segmentation, as in the previous image I have shown, that attributes now, it comes to the analysis and finding out the attributes. So your input is the image. Output, what you are giving, this is not image. You are generating some information, generating some attributes. What type of attributes? I have 3 different classes, and these are the petal length, petal width of particular object, and we are identifying which class it belongs. Say I have a flower of 3 different categories with different length of the flower, color of the flower, all these things. And now I want to, from the image of that flower, I want to find out which category this flower belongs. So in the result, you will not ask for the flower image. You are asking for the category based on few characteristics. What are the characteristics? Say color of the flower, length of the petal, or the particular shape, round or long tube shape, this sort of thing. So those are basically represented by few parameters. You can say the shape of the image, circumference, area, all those things can be parameters. And when you plot in the graph, the particular class, say I am having 2 class flower, class A and class B. Class A, all the parameters will be actually appears nearby. And if it is not in this class, it belongs to other class. And the similar other flowers with those characteristics, their parameters will also be clustered. So this sort of thing comes under the scope of object recognition. It's not only flower, there are several ways to identify the flowers or to identify the particular class of the given object. Now, next one is the representation or description. What is representation? I have the image. See, this is my object. And this is my object present in this image. I want to find out the representation and description information. What is representation and description? Maybe the information about the boundary. So, without storing the image, I can store the information about the shape of that image. And you can realize that that saves huge volume of area, storage space. Because if I want to store the image information, the entire image, so many pixels, 8 bit per pixel at least I need to store. And without storing that, if I want to store only the boundary information, because I need only the shape information of that image. I don't need the color, I don't need the other information. So you store only the shape information. Shape information means this is actually, say, starting from any point. I am moving in a particular direction. I have just identified the 4 directions, left to right, 0, top to bottom 3, right to left 2, and bottom to top 1. With these 4 numbers, I have represented the entire boundary. And you can represent the entire boundary in form of, say, 0, 0, 7, 1, 0, 0, 1, 3, 2, 1, like that. And you will have the clear idea that how the shape appears. Similarly, you can consider 8 also, 8 directions also, like consider the diagonals also. Up, down, left, right, then top left, top right, the diagonal sides. Bottom left, bottom right. All 4 diagonals. So total it will be 0 to 7 directions. And this type of study is covered in the representation and description. Then we have the image compression, because total size, if I want to store, it will be huge. It will be difficult to transfer to your over internet or over any other communication medium. So we always prefer to compress the image without losing the actual information. You are familiar with the JPEG, .jpg files, image files, .mpeg, the video files, all these are compressed image. At the same time, we are having color image processing also. These are the different types of image, your PNG or .jpg, all these things. And these are the color image informations. So this, in a nutshell, this diagram actually represents what all things we are actually doing in image processing. Now, why should we learn these things? Where we apply? Let us come to the application part. All of you are familiar with the document handling. Say you want to perform some kind of digitization of old documents, library books, or you want to identify handwriting, this sort of thing. Signature verification. In bank, they are doing signature verification. They are also running some software which implement the image processing algorithm for signature verification. This is a very good application of image processing. How you can find out the characters of the signature, particular shape, particular position of the pixels. Every person is having specific handwriting. Huh? Yes. Any question? Okay. So every person is having specific handwriting and specific properties of this handwriting. So based on that, you can have unique signature and we can generate the automated process which can verify the signature. Biometric. As I have already mentioned, biometric, you can have the thumb impression, you can have the iris image analysis for biometric, then your face. You know that now you can open your mobile, unlock your mobile from face recognition. That is a application of computer vision. Fingerprint verification. As I have already mentioned, the fingerprint verification biometric database can be maintained. Then fingerprint identification research. There are several institutes which are performing their research, continuing their research on fingerprint. Then object recognition and identification of objects, identification of special objects in your scene. Shape, you perform index and indexing and database you can develop for that. Color and texture. Then this is another very important application in defense, target recognition. They always develop the simulation software based on computer vision to identify which are the targets, where they have to hit. So that portion is there. Satellite image. That is another vast domain of study where the aerial photography, not only satellite, even from aeroplane, helicopter also, you can perform the aerial photography of the particular zone. You can find out position of the buildings. These are also very important for our defense, as well as the satellite image analysis, satellite image processing, and application of computer vision in satellite image. That's vast application in agriculture, in natural disaster handling like flood prediction, rain prediction. All these things can be done by applying computer vision knowledge and analyze satellite image using computer vision. Then autonomous vehicles. You know that autonomous parking. Now people are having the driverless car. Even in Calcutta, we are having metro rail running driverless. So this kind of, any kind of autonomous vehicle operations that comes under the computer vision knowledge, computer vision research domain. Traffic monitoring, automated traffic monitoring. Whether your car is violating the line in 6-lane, 12-lane road, or it is violating traffic rule, those things can be tracked automatically from the traffic video surveillance or traffic camera monitoring, and you can have the software developed using computer vision knowledge to track those things. Face detection is a very common problem. Face recognition and the facial expression recognition. That is also facial expression, whether you are crying or laughing or you are surprised or you are feeling sorrow. All these things can be performed through computer vision application and through image processing, face tracking, and human-computer interface, sign language recognition. There are plenty of applications here. Human activity recognition, whether you are performing, you are having any abnormal activity, like here exchange of some particular goods, interaction, kind of interaction, all these things. Then disease diagnosis, whether disease is present in that image or not. Like this is given the example of skin cancer and breast cancer, the mammogram image and the skin cancer, the skin image. So these things, morphing, it's a very common process of computer graphics. Replace a particular face with something else, or a particular portion of any image with something else. So those type of things are the applications. And optical character recognition, this OCR, given any handwritten character, your program can identify what it is written. So there are huge projects from last 10-15 years. People are working on this OCR. Then, as I have mentioned, this goes to the extent of sentiment analysis, and there is another branch of artificial intelligence who are working on natural language processing, on NLP. NLP and computer vision and artificial intelligence. All these are very related. So we are having that type of applications. And 3D from thousands of images. I hope all of you are aware about the medical imaging like MRI, magnetic resonance image, or computed tomography, CT scan. Now, whenever there is any complication, doctors ask us to go for MRI or CT scan. There also, we are generating a certain number of images, and then we can generate we can collect all these 2D images from the 3D image to find out the depth-wise information. 3D means you are having the additional Z direction. That means X, Y, Z. So you are having the depth information also. And depth information means, say, someone is having tumor in brain. When you are taking the image, you have the tumor image available in 2 dimensions. You can't comment on what is the depth of the tumor, how much it has penetrated in the brain. So once you can generate the 3-dimensional image, then only you can visualize the depth. So there are several applications, not only in medical image, there are several applications where this 3D information is very important. Even reconstruction of archaeological monuments, archaeological artifacts. This application of formation of 3D, computer graphics and computer vision, they are very useful. And they are also computer scientists are working with archaeologists to reconstruct or restore the age-old monuments, age-old statues, all those things. So there are several domains, several applications where we can have this sort of thing. One application of biometric, where this particular lady, it was difficult to identify from this image. And finally, they apply the iris image of her eyes and perform the iris signature matching to identify the particular lady. So they are having several applications. And these things, log out without password, all these things you are familiar with. Special effects, 3D movies, or any kind of movie with both actor and animated actor. Those things nowadays we are very familiar. Like this movie, the scene is taken from Matrix movie. So this type of movies, they are using computer graphics, they are using computer vision to generate or to perform the operations, perform their imaging and other operations, special effects in motion, and the sports. You know the role of third umpire. How he is taking decision. Most of the case, third referee or third umpire, they are watching this in slow vision, as well as they have the software also which can identify whether any foul, any kind of malpractice done in that particular field, or whether in case of cricket, whether it is out or it is not, it has touched the bat or not, those kind of things. So all these are application of computer vision. So I am not going in detail about how we are doing, because before that you need to study a lot about the subjects, then only we can discuss those sort of things. But at least the application part I have mentioned here. So any question from audience?
Students, if you have any question, please ask, ma'am.
So initially someone was asking, I hope he now has some idea of what we are discussing about.
Yes, ma'am. Sure, I hope so.
Main objective of this lecture is just to give you some idea about the terminologies we are using, what we can do with this type of topics.
Yes,
And
ma'am.
I hope you will feel interested. You will have some interest to
Yes,
study
ma'am.
this domain in future.
This is a very new topic and a new domain or a
Terminus
new
means
spectrum.
a terminal emulator.
Yes, Tushar?
টার্মেক্স তো স্যার টার্মিনাল ইমুলেটর এক ধরনের, এখানে নানা রকমের মানে কি টুলস তৈরি করাও যেতে পারে, এমনকি লিংক দিয়েও অনেক কিছু কাজ করা যেতেও পারে, যেটা কালিনিলাক্সে হয় ঠিক অতটা ঠিক হয় না।
আচ্ছা, ম্যাম কে কিছু
কিন্তু কিছু
কোশ্চেন
কিছু
করছো
কমন
কি?
কিন্তু সাপোর্ট করে স্যার।
তোমার কোশ্চেনটা অ্যাকচুয়ালি প্রপারলি বোঝা যাচ্ছে না।
হ্যাঁ, অ্যাকচুয়ালি তুমি কি জিজ্ঞেস করতে চাইছো সেটা বলো, মানে এনিথিং রিলেটেড টু দিস টপিক? Emulator is a different thing.
তুষার, প্লিজ আস্ক, ডোন্ট হেজিটেট, জিনিসগুলো ক্লিয়ার করে নাও। দেখো, আচ্ছা তুষার, আচ্ছা হয়তো একটু ম্যাম একটু হেজিটেট করছে।
হ্যাঁ, ঠিক আছে।
হ্যাঁ ম্যাম, আর কারোর কোনো কিছু কোশ্চেন আছে? If anyone have any question regarding the topic, so we can see from the lecture that in each and every field of engineering, computer vision is needed. As ma'am has said that for archaeological development or for safety engineering, for detecting motion, detecting facial recognition, many of the things which are related to all the departments or all the fields of engineering, maximum of the fields which we are studying in our college, right? Those are interrelated, and we are going to study more on this. So I hope all have gained a special knowledge on or a new thing about what you can do in your future after studying, whether you're studying civil engineering or you're doing mechanical or electrical. This
Any
is
branch
close
of application.
any branch of, yes ma'am. For computer
Actually,
science,
what is
yes.
happening is, see, in school level we are using this multiplication table and the basic mathematical operation like your division, multiplication, subtraction, all these things. The same days are coming within next 5-10 years. Machine learning will take that part in the higher studies. Every domain of engineering, machine learning will be a tool.
Yes,
This
ma'am.
artificial intelligence will be a tool, and this computer vision is related to that. That's why
Yes,
it has
ma'am.
application in all domains.
Yes, ma'am. Today morning only, ma'am, I was engaged with a one training with KIET Ghaziabad. They were
Mhm.
also speaking about this image processing, how defense is using this image processing for hit and miss. They are entering the images and how to target the position, how many objects are there.
Yes.
All these things are there very well. They are doing for the defense organizations. So
Hello,
it
ma'am.
yes, Pritam.
I have one question, ma'am.
Yes. Yes.
Ma'am, how we can identify means how we can change means how we can identify the gender by using image processing?
See, gender identification, any kind of identification, if you want to do, normally we used to go for any supervised model in machine learning. You will have a setup, you will have a model where you will train your system with different images. Say you are having 500 image of male starting from age 1 to age 70. You are having 500 image of female starting from that range, and you will train your system for every image. You will mention the class. Now class is male or female, two types of classes, and you train your system with this entire data set. Now if you give any image of any male or female, your system, trained system, will be able to classify, because it knows which are features the male or female have. It's not only male or female. The similar way we are identifying any kind of object like cat, dog, or tree, or vehicle, whatever. That is
If
the
if ma'am
supervised
some
identification.
person have both the characteristics means of
It
means
is not the characteristic you are visualizing. Given the image, how it visualize the characteristics. It is not the physical
uh,
characteristics of the
means the
appearance.
appearance I am saying, ma'am.
Yes, it is not the
If
appearance your
someone have
computer vision is visualizing. That's what I have mentioned at the beginning. When we are visualizing with the physical appearance, some properties in that particular shape. But when computer vision is visualizing, it is considering the entire image in form of a matrix. And then within that matrix, it is forming the small matrix. Say your total image size is 600 cross 800. You will have the image size. You will have the cell size of 3 cross 3 or 5 cross 5 kind of thing. You proceed throughout the image. Your program will proceed throughout the image and find out the characteristics of each of these 3 cross 3 or 5 cross 5 cells and perform its operation. So now, if there is any confusion, it based on how good you have trained your model. If you have trained your model with all kind of possible images of those classes, then definitely your model should give you the correct result. And if it is not only based on the dress, it is not only based on the hairstyle, not only based on the physical appearance, whatever way you have trained it is based on that it is giving. Because I can tell you something like it happens that someone trained a model with, apartheid is very burning problem in USA and the Western countries. So someone trained a model with the images of white person, images of black person, images of gorilla, and just maybe there are some political thing or some apartheid related issues. System identified a black person with a gorilla, termed is in the class of gorilla. That is possible because it based on, that is called bias training. You have not trained the model properly with all type of varieties. If you train it properly, definitely you will get the correct result. Or that depends, that ensure that how good your system is designed. And there are plenty of models available now. People are proposing, even with the new problems, new models are coming up. to increase your efficiency of classification. This is basically what you are mentioning is a classification problem. Yes, Pritam,
Okay,
it's okay?
thank you, ma'am.
Ma'am, I have a question actually.
Yeah.
Ma'am, what tools can we use for this image processing or the image recognition or this kind of things to do research on this kind of things?
Can you please repeat?
What kind of tools, ma'am, we can
What kind
use?
of tools?
Yes, ma'am.
Okay. Tools means actually, are you mentioning about the programming language and the environment?
Maybe, ma'am. I think for today's training I was having that they were practicing with MATLAB. They were giving practice with MATLAB
Yes.
about the image processing. Other than MATLAB is a little hard for the students also in diploma level.
No. So I don't think so. Actually, that point is, MATLAB, Scilab, PSpice, all these softwares are having two things. One is the programming part, another one is the simulation part.
Yes, ma'am.
And both can be done. But the main problem is these are proprietary items. This Scilab is open source, but MATLAB and this is a proprietary item you have to purchase from your institute or personally, and this is costly.
Yes, ma'am.
And another thing is, as it is a proprietary item, in many cases, whenever they change the version, maybe MATLAB, if you are using 2015 RB version, your present version program will not run there because you are calling some function, some tools which was not available in that version. So this version mismatch problem is also there. Now, the best option what we find as computer scientists is the Python environment, which is freely open source, freely available, and Python with any kind of flavor. There are several versions of Python available. At the same time, in Google, if you search properly, you will get the entire instruction of how to install and how to work with that. And most interestingly, say these computer vision problems are whenever you need high memory size to execute your program. These vision problems, you understand, we are dealing with images and videos. So the requirement for memory is very high. You will not have i7 machine sufficient for running computer vision programs. i7 machine will be slow. So you need GPU. Now it is not possible for many institute and individuals to afford GPU. GPU minimum cost starts from 7 lakhs, 8 lakhs, standard GPU.
Okay.
So the option available for this Python is Google, they are providing the environment of Google Colab with free GPU. So anyone who is developing programming in Python can open the Google Colab, which is very simple. From your Gmail itself, if you right click and find out, you will in your Google Drive, if you right click, you will find out the Google Colab environment. So you can go to Google Colab environment, you can write your Python code, you can use their GPU, they are giving you free GPU up to a certain limit. So you can perform it, but from MATLAB that is not possible. You need high-end machine. You need the speed as well as you need the software.
Yes, ma'am.
So there we have the limitation. I think better to start with Python so that this resource restriction will not be there. That is very important for any researcher or any higher study.
Thank you, ma'am. Thank you very much. Any
Thank you.
students have any other queries?
No, sir.
Okay. We have faculties among us also from our institute. Any of the respected teachers have any queries?
I have a question. I found the overall webinar is very good, very informative for me.
Yes, ma'am.
Thank
I
you.
have a question whether there is any application of this particular segment in microscopy.
Ma'am, can you please
Madam?
repeat?
Whether there is any application
Application
Whether there is
means
any application in microscopy, in
Micros-
scanning electron microscopy. Yeah.
you are talking about the microscopic image?
Yes, madam.
Definitely. Microscopic image, actually, this is a specific domain, I can say, because we are dealing with actually I am working with medical image. So from medical perspective, I can say we are dealing with two types of image. One is macroscopic world and it's microscopic. Macroscopic means you can say X-ray, MRI, CT, all this comes microscopic. But what about your blood slide? Blood smear is microscopic. So any kind of microscopic image, cell image, or the leaves, or all these things, any microscopic image, you can perform the object detection classification. That is a very good domain, and people are working on that using computer vision.
Thank you so much.
So, any other queries? Okay, I hope there are no queries. So, with that, I conclude the session. I again thank on behalf of Sri Ramakrishna Institute. Ma'am, thank you for giving us time and enlightening us with a new spectrum of knowledge, and for the students as well for the faculties. And I have also learned many things today, which will help me in doing something innovative in future. So thank you, ma'am. Thank you for giving us time.
Okay, thank you all for listening.
Thank you.
Thank you, ma'am. Thank you very much.
So I'm closing it here.
Okay, ma'am. Thank you, ma'am. আচ্ছা, স্টুডেন্টদের জন্য বলে দিই, কালকে আমাদের আরেকটা ওয়েবিনার আছে ফ্রম 5 PM। ডক্টর সন্দীপ কুমার লাহিড়ী স্যার আসবেন ফ্রম এনআইটি দুর্গাপুর। সেখানে এনআইটি দুর্গাপুরের হয়তো কিছু স্টুডেন্ট ফ্যাকাল্টিজরা থাকবেন, যেহেতু ইট ইজ আ কোলাবোরেটিভ ওয়ার্ক উইথ এনআইটি দুর্গাপুর অ্যান্ড শ্রীরামকৃষ্ণ ইনস্টিটিউট। তো উনি ফর বোথ দ্য ইনস্টিটিউট উনি লেকচার দেবেন। তো সবাই 5টার সময় আবার জয়েন করুন। টিচারদেরও বলছি, স্যার ম্যাডামরা আপনারাও থাকবেন। সবাই আপনাদের সাপোর্ট ছাড়া সব প্রোগ্রামেই আনসাকসেসফুল থেকে যাবে। তো টিচার্সরা সবাই থাকবেন সাথে, স্টুডেন্টরা টাইমলি 5টা থেকে জয়েন করে যাবে, ঠিক আছে?
Okay.
থ্যাংক ইউ ম্যাম, থ্যাংক ইউ স্যার।
হ্যালো স্যার। হ্যালো।
হ্যাঁ
বলো জাহিদ বলো।
হ্যাঁ জাহিদ বলো।
ওই সেমিনারটার মধ্যে কি নিয়ে আলোচনা হবে স্যার?
কালকে কিছু হোয়াট ইজ ইনোভেশন, মেনলি হাউ টু ডু ইনোভেশন, ঠিক আছে? হ্যাভিং সেটিং আপ দ্য ইনোভেশন মাইন্ডসেট, এগুলো নিয়ে ডিসকাশন হবে, ঠিক আছে? কালকে কোনো সাবজেক্ট স্পেসিফিক হবে না, একটা ওভারঅল একটা ডিসকাশন হবে, যেটা সব ডিপার্টমেন্ট থেকেই। তো 5টা থেকে দেখবে, সব স্যার ম্যাডামরা তো দিয়ে দিয়েছে গ্রুপে, তোমরা দেখবে, ঠিক আছে? লিংকটাও আমি দিয়ে দেবো, ঠিক আছে? আর হয়তো আরেকটা জিনিস হতে পারে, হয়তো 2 তারিখে, সেটা এখনো কনফার্ম নয়, 2nd of July there may be another session of building a product fit for market. How you are going to make your own product that can be sold to the market, that can be made to the market for your customers, ঠিক আছে? That will enhance your entrepreneurship or startup skills or startup mindset, maybe not the skills, that will be mindset. তো সেগুলোর উপরে হবে হয়তো 2 তারিখ approximately, ঠিক আছে? টেন্টেটিভ, সেটা এখনো কনফার্ম নয়। আফটার কনফার্মেশন আই উইল ইনফর্ম দ্য ডিপার্টমেন্টাল টিচার্স, তো তাদের থেকে তোমরা জেনে যাবে।
হোয়াটসঅ্যাপ গ্রুপে ফলো করবে, লিংক দেওয়া হবে, জয়েন করে নেবে, ঠিক আছে? আমরা ওয়েবিনার এইভাবেই চালাবো, স্যার বলছেন ওই নম্বর।
আমরা নতুন টপিক নিয়ে ডিসকাশন করব আদার দেন সাবজেক্ট, যাতে তোমাদের একটুখানি ব্রড স্পেকট্রামে তোমরা ভাবতে পারো, এই আর কি।
সেটা হ্যাঁ, ওদের পরীক্ষা হয়ে গেছে, আজকে পরীক্ষা শেষ ছিল।
হ্যাঁ ওই জন্যই মাঝখানটা আমি একটুখানি গ্যাপ দিয়ে দিয়েছিলাম, যাতে পরীক্ষাটা সময়টা যাতে এনগেজ না করতে হয়।
মানে আজকে শেষ হয়েছে, আজকে এই ওয়েবিনারটা হলো, যাক জয়েন করেছে।
হ্যাঁ
সবাই জয়েন করেছে।
হ্যাঁ স্যার। খুব ভালো
ভালো
লেগেছে
লাগলো
স্যার।
আজ এই
হ্যাঁ
প্রোগ্রামটা খুব ভালো লাগলো, মানে এইসব প্রোগ্রাম গুলো না করলে
হ্যাঁ, ইমেজ প্রসেসিং স্যার এখন তো সব জায়গায় কাজে লাগছে, আমাদের সব জায়গায়। আমাদের ধরুন কলেজের আমরা অ্যাটেন্ডেন্স সিস্টেমও ইমেজ প্রসেসিং দিয়ে বানাতে পারি না? আমাদের গেটের সামনে যদি আমরা ওরকম ক্যামেরা লাগিয়ে রাখতে পারি যে আমরা ঢুকছি তখনই আমাদের অ্যাটেন্ডেন্স হয়ে যাচ্ছে। why to go for biometric thumb imprint or register signing, তাই না? তো
এই
সেখানে আমরা
ফলগুলো ওরা বুঝতে পারবে, আবার যখন বড় হবে ওরা আবার স্টাডি যখন করবে, এরা এই
হ্যাঁ
এই যে
হ্যাঁ হ্যাঁ
করেছে বা জানলো ব্যাপারটা, এটা
হ্যাঁ
তখন ওরা বুঝতে পারবে যে
স্টুডেন্টসরাই বানাতে
গুরুত্বটা
পারে
বুঝতে
তাই না,
পারবে।
এরপরে স্টুডেন্টসরাই আস্তে আস্তে এরা বানাবে,
হ্যাঁ ম্যাম, একদম
বানাতে পারে তাই না স্যার?
একদম ম্যাম, একদম এগুলো
তাই
নিয়ে।
বানালে আমরা খুশি হব।
হ্যাঁ, সিভিলরাও ধরুন এখনকার দিনে যে স্ট্রাকচারাল ডিজাইন গুলো সেগুলো ইমেজ প্রসেসিং দিয়ে হয়ে যাচ্ছে। যে যদি ব্রোকেন স্ট্রাকচার গুলো রিপেয়ারিং হয়ে যাচ্ছে,
স্যার
3D
অটোকাড বলে একটা অটোকাড নাকি একটা সফটওয়্যার আছে স্যার, দেখছিলাম।
AutoCAD, হ্যাঁ AutoCAD আছে। Fusion 360 is more viable for this kind of designing process. এছাড়া তোমার যেন ম্যাম বললো পাইথনটা, হ্যাঁ তো সেইখানে সেইটা শিখবে। আমি দেখছি এটা পাইথনের যদি একটা ছোট্ট বুট ক্যাম্প টাইপের অর্গানাইজ করা যায়, ঠিক আছে? পাইথনটা তোমরা যদি শিখে যাও এখন থেকে তোমরা হ্যাঁ
আরেকটা পিডিএফ এ দেখলাম, মানে এই পিপিটি তে দেখলাম ওই ম্যাট্রিক্স ফর্ম গুলো বলছেন, মানে ম্যাট্রিক্সের এটা ওগুলো ফার্স্ট ইয়ারে বুঝতে পারবে না ম্যাট্রিক্সের
হ্যাঁ
ব্যাপারটা, ওটা সেকেন্ড সেমিস্টার ওদের আছে, ওটা পড়া বুঝিয়ে দেওয়া হবে। ম্যাট্রিক্স ফর্মটা কি, কত ম্যাট্রিক্স, ওটা যারা সেকেন্ড ইয়ার থার্ড ইয়ার তারা বুঝতে পেরেছে মনে হয়। ফার্স্ট ইয়ারটা যারা এইচএস পাস করে এসেছে সায়েন্সে তারা বুঝতে
হ্যাঁ
পারবে ম্যাট্রিক্সের এইগুলো,
হ্যাঁ স্যার,
ঠিক আছে মোটামুটি।
এই ওয়েবিনার গুলো সব মিক্স করে তোমাদের কিছু একটা তৈরি করতে হবে। মেন ব্যাপার যে ফোকাসটা ধরো এই যে অপটিমাইজেশন, কদিন আগে ডক্টর কিং সুগিরি বলেন অপটিমাইজেশন, আজকে ইমেজ প্রসেসিং, কম্পিউটার ভিশন, তারপরে এছাড়া ধরো এআই, অগমেন্টেড রিয়েলিটি, আইওটি, এগুলো দিয়ে আমাদের ধরো সব ডিপার্টমেন্টেই কাজ হচ্ছে। এগুলো কোনো স্পেসিফিক ডিপার্টমেন্ট না যে হ্যাঁ এগুলো কম্পিউটার সায়েন্স বা ইলেকট্রনিক্স এর লোকেরাই করবে, না, এগুলো সবাই করবে।
ডিপার্টমেন্ট
হ্যাঁ
প্রত্যেকটা কাজে লাগবে এগুলো,
সবার কাজে লাগবে।
সবারই কাজে লাগবে। হ্যাঁ,
তো থ্যাংক ইউ স্টুডেন্টস, থ্যাংক ইউ অল ফর জয়নিং। কালকেও আমরা এরমই রেসপন্স চাই তোমাদের কাছ থেকে। আমরা সব টিচাররা সেটাই এক্সপেক্ট করি তোমাদের কাছ থেকে, গুড অ্যামাউন্ট অফ রেসপন্স। And thank you teachers for joining. Thank you for all your support.
ওকে,
Thank you sir, thank you ma'am.
ওয়েলকাম ওয়েলকাম।
ওকে, থ্যাংক ইউ।
Thank you ma'am.
থ্যাংক ইউ স্যার, ওয়েলকাম।
Thank you sir, thank you.
রাখছি তাহলে।
হ্যাঁ স্যার, ঠিক আছে স্যার।
ভালো থাকবেন। হ্যাঁ ঠিক আছে।